we said, because we have a sample that's hot, cobalt metal, going into water, we're going to be able to set the Q's equal to each other, because eventually the heat is going to be equal. Okay? So which one is going to be negative? Well, remember what a negative Q means. A negative Q means that I'm expanding. Exothermic versus endothermic, or remember that the negative or positive sign tells us how the heat is flowing. Okay? And so which one is going to give heat to the other? Well, which one's warmer, the metal or the water in this problem?
The metal.
The metal's warmer, so it's going to get my negative symbol. Okay? All right. So we make this negative, and the reason we make this negative is because it's going to be warmer, transferring heat to the cooler substance. So what we're going to do next is we're going to set up our problem. So it's going to be negative M times C TF minus TI. And this is all about the metal. This side's all about the metal. I'm going to put M up there. And then this side is going to be M times C times TF minus TI. And this is about the water, because we made that side the water. Really wouldn't matter what side I made what. I could put the Q and the M and switch them, the QH2O and the QM and switch them, as long as I have the negative with the M, because it's a warmer substance, so it's going to transfer heat to the cooler substance. All right, now, I'm going to leave my negative out here. For now, we'll deal with that later. But before we get into the math, I want to make sure we pull our variables correctly. So we know we need to find an M for this side, a C for this side, and we know we need TF and TI. So what is the mass of the metal? This is the mass of the metal, 85.18 grams. I got that from a paragraph above. I gave me the specific heat of this cobalt, 0.440 joules over grams times degrees Celsius. We're looking for TF. Remember, the TFs will be the same TF, and that is because both of them are going to get to the same final temperature. Okay, both of them are going to get to the same final temperature. All right. So what is my initial temperature? My initial temperature for the metal is 102.3 degrees Celsius. Okay? All right, now we've got all the data we needed for the Q for metal. Let's get the data for the other side. So mass equals. Now, do you see a problem that we have right now? Do I have the mass of water? I have the what of water? I have the volume, yes? But remember what we know. We know that density equals mass divided by volume. So I can solve that mass for density times volume would be the formula for solving for mass. We know we have 325.0 milliliters. Does anybody know the density of water? Nope, that's the molar mass of water. 1, I saw some people mouthing it, gram per milliliter. So that means that if we have water and we know the volume, we know the mass, because the density is 1. So then we can say 325.0 grams. Now, where does the C for water come from? Your blue cards. Your C for water is on your blue cards. I bet you're going to memorize it for the end of this unit because you're going to use it so much. 4.18 joules over grams degrees Celsius. Okay, and then we have TF, which we don't know because that's what we're solving for. And then TI for the water. How does the water start? 25.58 degrees Celsius. All right, let me pause there. Any questions on that? All right, so the next thing we're going to do is we're going to plug these numbers into that formula up above. I'm going to rewrite it just so that I have space so you guys can see what I'm doing. So we said it was negative M times C TF minus TI. That's for the metal side. And then M times C TF minus TI for the water side. Okay, so we're going to plug in our values from just pretty much right above. So I'm going to keep my negative outside that parentheses for a while. just so that I don't lose it when I'm working with my algebra. So all I'm going to do is plug in the numbers going all the way across. So 85.18 grams and 0.440 joules over grams degrees Celsius. Remember, your TF is what we don't know. But we do know the beginning temperature. Sorry, 202.3 degrees Celsius. Is that the right temperature? Yeah. This is a 2 here. We know the mass of water, and I'll move out of the way so you guys can see this in a minute. All I'm doing is... What did you say?
It's 102.
102. I knew that didn't feel right. Thank you. Yeah, 102.3. And then 4.18 grams, joules over grams degrees Celsius. And then TF minus 25.28 degrees C. Let me raise that so you can see that. This should have been 102.3. And that last number is 25.28. I got that right out of my chart. Oops. Okay. Questions about that piece before I go on?
Please do not show off.
All right, so the next step I would do is, if I was encouraging you to do it a certain way that has success, is to multiply these two numbers first and the two numbers on each side of the equal sign. So I'm going to mark multiply. I'm going to leave my negative in here right now, on the outside I should say. I'm going to multiply 85.18 grams times 0.440 joules grams degrees Celsius. So I'm going to do that part. And on the other side, I'm going to multiply 325 grams times 418 joules grams degrees Celsius. Now, when I do that and I account for sig figs, I get 37.5 joules degrees Celsius TF. So what did I do? I multiplied 85.18 grams times 0.440 joules per grams degrees Celsius. And it's not a TF yet. I don't want to distribute yet.
Do grams cancel?
Grams would cancel. Everybody see that grams cancel? Because grams is on top here and bottom there, so they cancel. And then I'm going to keep this part here in there for right now. I'm not going to do I'm going to do some small steps with you just so you can see what I'm doing algebraically. Do the same thing on the other side, meaning I'm going to multiply mass times C. In this case, 325 times 4.18, which I get 1360 joules over degrees Celsius. Again, grams would cancel because grams times joules over grams degrees Celsius would cancel. And then I still have my TF minus 25.58 degrees Celsius. Should have been 25.58 there, not 28. All right, now mathematically, what are we going to do next? First of all, is everybody okay with that piece? If not,
Distribute.
we're going to distribute. Now I'm going to deal with that negative symbol. I really should have a parentheses here. So it's going to be negative 37.5 joules degrees Celsius TF, because that TF is just like an X. What happens when I multiply 37.5 joules degrees Celsius times 102.3 degrees Celsius? I get rid of what? The negative becomes positive, because I'm going to do negative times a negative, and what happens to my units? Degrees Celsius goes away, right? So this will be 3840 joules. Basically the same kind of thing on the other side. I'm going to take 1360 joules degrees Celsius TF minus, because there's no negative symbol to carry through, so it's going to still be minus, and then I'm going to multiply 1360 times 2558, and with sig figs, I get 34,800 joules, because degrees Celsius would cancel, because joules degrees Celsius times Celsius gives me joules. All right. right, now what do I have to do mathematically? Can't divide. Gotta get like terms together, yes? Okay, so I gotta get my TFs together. I have the TF on one side and the TF number on the other side. And my non-TFs, those are the 3840 and the 34800.
13.
Okay, I want to get them all together. So I'm just going to get my TFs on the left and my non-TFs on the right. It doesn't matter which way you do it, though. It'll come out the same way as long as you combine the right things. So when I have to subtract the 1360 TF from both sides to get both TFs on the left side. When I do that, it's going to be negative 1398 joules degrees Celsius TF. Again, what did I do? I subtracted the 1360 from both sides. When I subtract 1360 from the right, it goes away. And then when I bring it over here, I have a minus plus a minus. That's why it's negative 1398. Then I'm going to subtract 3840 from both sides to get my non-TF on the other side. When I subtract 3840 from negative 34800, I get 38,640 joules. Using sig figs, that's what I get. And it's negative. Because I had a negative minus a negative. All right, now what are we going to do to get TF by itself? Divide both sides by 1398. So divide both sides by 1398. And they're both negative, so the negatives cancel. And I end up getting 27.64 degrees Celsius. Now, how do I end up on degrees Celsius? What happens to joules? Joules will cancel. So this is your final answer.